Last week we looked at solving systems graphically. Remember, system was two lines on the same grid, and we had to find the point of intersection. But sometimes those lines, when they intersect, don't intersect at nice points. So we need a different method to find the point of intersection. We're going to use algebra for the next couple days to find the points of intersection. Today what we're going to focus on is using the substitution method. You remember the substitution method from last year. Now, in order to solve a system using substitution, the first thing you want to do is solve one of the equations for one of the variables. That means either equation can say x equals or y equals. Usually what we do is we look for the easiest equation to solve for. After you solve for an x or y in the first equation, you substitute that expression into the other equation. And you're going to solve that equation. You're going to get either an x value or y value that you're then going to substitute into any one of the other equations that has both variables and solve for the second variable. And then we're going to do a check by substituting both values into both original equations. Now let's take a look at the first example. What is the solution of the following system? Use substitution. So remember, the substitution method says we want to have one of the equations say x equals or y equals. So we take a look at our two equations and we look for an equation that says x equals or y equals. Since the first equation already says y equals, we take the expression that it's equal to and we substitute it into the second equation. So now for the second equation, instead of having x plus y, we're going to have x plus what y is equal to, which is 3x, equals negative 32. Now we're going to go ahead and solve this equation since we only have one variable now. We're going to combine like terms and divide both sides by 4. So our x value for the system of equations is going to be negative 8. That means the x value of the ordered pair where these two lines intersect is at negative 8. Remember, we had to find an ordered pair when we did this last week. That meant we have an x and a y. So now what I have to do is I have to use this x value to go back and find the y value that matches it. You can go back to either original equation to find your y value. Usually we use the easiest one. In this case, it would be the first equation. I start with y equals 3x. And now that I know that x is negative 8, I substitute the negative 8 in for x. That means that y is equal to negative 24. So the ordered pair where these two lines intersect is the point negative 8, negative 24. You have to make sure you write your answer as an ordered pair, otherwise points are going to come off. Now what we're going to do is we're going to check to make sure negative 8, negative 24 works. And remember, when you check, you have to check the x and the y in both equations. So what we're going to do is we're going to check the ordered pair negative 8, negative 24 in the first equation, y equals 3x. The y value we found was negative 24. The x value we found was negative 8. And 3 times negative 8 is negative 24, so that checks. That does not mean that that's the answer to the system. All that means is that the point negative 8, negative 24 is on the line y equals 3x. We have to make sure that the point negative 8, negative 24 is on both of the lines. So now we're going to check negative 8, negative 24 in the second equation, x plus y equals negative 32. We said x was negative 8 and y was negative 24. Negative 8 plus negative 24 is negative 32. Since the ordered pair -8, -24 is on both of the lines, that means that this is the point of intersection for those two lines. So your answer of -8, -24 is correct. Let's take a look at the second example. What's the solution of the following system? And again, we have to use substitution. Remember, step 1 says we want to make one of the equations say either x equals or y equals. Right now, neither one of those equations say x equals or y equals. So what I'm going to do is I'm going to look for the easiest equation to solve for one of the variables. Since the second equation has a y that doesn't have a coefficient, that's going to be the easiest equation to solve for. So what I'm going to do is I'm going to solve the second equation for y. In other words, I'm going to get y by itself. What I need to do is add 2x to both sides. And I get y equals 2x minus 3. Now, step 2 says take that expression, whatever the y is equal to, and substitute it into the other equation, the one that we didn't use, which is the first one. So now instead of 3y, we're going to have 3 times the value of y, which is 2x minus 3. And then the rest of the equation, plus 4x, equals 14. Now the nice thing is that we have an equation with one variable, so we're going to go ahead and solve that. Use your distributive property. 3 times 2x is 6x. 3 times -3 is -9. Plus 4x equals 14. Combine your like terms. 10x minus 9 equals 14. Add 9 to both sides. So 10x is 23. Divide both sides by 10. So x is equal to 2.3. Now remember, we're looking for an ordered pair. We don't want just the x. We have to find the point of intersection. So what we need to do now is go back and figure out what the y value would be for this ordered pair. When you're looking for the second variable, you can use either of the two original equations or the one that you transformed. So you can use 3y plus 4x equals 14. You can use -2x plus y equals -3. Or you could use the one that we created, y equals 2x minus 3. I'm going to use the easiest one, which is y equals 2x minus 3. Now we're looking for y, and we found what x was, which was 2.3. Two times 2.3 is 4.6, minus 3, which is 1.6. So the ordered pair, the point of intersection between these two lines, is 2.3, 1.6. Now that would have been a difficult ordered pair to find on the graph. We wouldn't have been able to come up with it, so we had to use algebra to find that. Remember, to check this ordered pair, you want to take both the x and y and substitute it into both original equations to make sure the ordered pair works for both lines. Okay, let's take a look at number 3. This time, number 3 asks, how many solutions does each system have? In other words, is there going to be one point of intersection, no points of intersection, remember those are parallel lines, or an infinite number of solutions? Remember, that's when we graph the same line over top of one another. So what we're going to have to do is solve this. Substitution says we want to get an x equals or y equals. Right now, the first equation says x equals, so we're going to take that expression and substitute it into the x of the second equation. Now, instead of 3.5x, we have 3.5 times the expression 4x, negative 2y plus 4, plus 7y equals 14. Now we're going to distribute our 3.5. 3.5 times negative 2 is negative 7y, and 3.5 times 4 is 14, plus 7y equals 14. Now when we combined our like terms, negative 7y plus 7y is equal to 0. So we're just left with 14 on the left-hand side. Now if you think back to earlier in the year when we were solving equations with one variable, and we got something that looked like this, where one side was equal to the other side, that meant that there was an infinite number of solutions. This is a situation where one line is directly on top of the other line. So all the ordered pairs that work for the first line will work for the second line. Let's take a look at number 4, or 3b. Okay, again, same idea. We want to find out how many solutions there's going to be. Okay, so since this is already solved for y, I'm going to take that expression and substitute it into the y of the second equation. So instead of y minus x, I'm going to have 3x minus 11 minus x equals negative 13. Combine your like terms. 3x minus x is 2x. Minus 11 equals negative 13. Add 11 to both sides. So we get 2x equals negative 2. Divide both sides by negative 2, or I'm sorry, by positive 2. And x is equal to negative 1. Now, since we were able to get an x, chances are we're going to have a solution. But if it doesn't work when we substitute it in for y, that means we're not going to have a solution. So remember, we can go back to either of the two original equations. I'm going to choose the easiest one. We're looking for y, and we substitute our x. Simplifying the right-hand side, 3 times negative 1 is negative 3, minus 11 is negative 14. So the ordered pair, the point of intersection, is the point negative 1, negative 14. But remember, the directions asked how many solutions. In this case, we have one solution. If we had a situation where when we're solving one of the equations and the variables disappear and we're left with a statement like 14 equals 13, which is slightly different than the one that we just saw, that means we're going to have no solution. Those lines are parallel. So it's possible to have one solution, no solutions, or an infinite number of solutions. No solutions, remember, means the lines are parallel. Infinite number of solutions, one line is directly on top of the other line. Otherwise, we have some intersecting point between the two lines, which will give us one solution. Okay, finally, number 4. A snack bar sells 2 sizes of snack packs. A large snack pack is $5, and a small snack pack is $3. In one day, the snack bar sold 60 snack packs for a total of $220. How many small snack packs did the snack bar sell? Solve using substitution. Now remember, when we're solving a system, we need to come up with 2 equations. We're also going to have an x and a y, which means 2 variables. So the first thing we need to do is figure out what our variables are, and then we need to name them something using let statements. Well, let's see. A snack bar is selling 2 sizes of snack packs. A large snack pack for $5 and a small snack pack for $3. So we've got large and small snack packs. I'm going to say let L equal the large snack packs and let S equal the small snack packs. Now, it tells me that in one day, the snack bar sold 60 snack packs all together. So the large snack packs and the small snack packs were a total of 60 snacks altogether. But they also made a total of $220. That means the money that they made off the large snack packs, $5 for every large snack pack, and $3 for every small snack pack, gave them a total of $220. There's your 2 equations with your 2 variables. Now remember, solving with substitution means you have to get one of the equations solved for one of the variables. The easier equation would be the first equation, since neither one of the variables have a coefficient. So in this case, it doesn't matter what you solve for. You can solve for L, make it say L equals, or you can solve it for S, making it say S equals. For this case, I'm going to make the first equation say L equals. So I have L plus S equals 60, and I want it to say L equals. So I'm going to subtract S from both sides. Then I'm going to take that expression, whatever that L is equal to, and substitute it into the L of the equation that I didn't use. So instead of 5L, now I have 5 times 60 minus S. I'm going to distribute my 5. 5 times 60 is 300, minus 5S plus 3S equals 220. Combining your like terms, you get 300 minus 2S equals 220. I'm going to subtract 300 from both sides, and I get negative 2S equals negative 80. Divide both sides by negative 2, so S is equal to 40. What that means is that I sold 40 small snack packs. Now, I should figure out how many large snack packs I sold. So remember that the large is equal to 60 minus whatever the small one was, and that came from this equation right here. So the number of large is 60 minus the 40 small ones, which means I sold 20 large snack packs. The question's asking me how many small snack packs did the snack bar sell, and I've already found that the answer is 40. Remember, in a real-world situation, we shouldn't have negative values unless it's something like negative temperatures. All of the number of items that I purchase, or price, or length, or anything like that has to be positive numbers. So if you're working in a real-world situation and you get negative numbers, something's going wrong with your arithmetic or your substitutions. Okay, for the remainder of the time that you have today, you're going to work on page 375, numbers 12, 16, 20, 23, 26, and 28. What I want you to do is I want you to practice checks with the first 3. So I want you to check 12, 16, and 20. 23, 26, and 28 you don't have to check.